Introduction. We created an audio player in Scilab. Through this process, we learned how to perform real-time analysis of audio and how to display the result graphically. Part 1. The objective of Part 1 was to write a Scilab function that will play and display a constantly update time domain plot. Part 2. The objective of Part 2 was to write a Scilab function that will play and display a constantly updated frequency domain bar chart. Part 3. Display. It is to display the audio player. We wrote code to display a window and graph. Button. It is to operate the audio player. We wrote code to display a button and to operate a button. Volume control. It is to adjust the audio volume. We wrote code to display a volume bar and adjust the audio volume. Open dialog. It is to select an audio file. We wrote code to display an open button and to use an open dialog. Change graph. It is to display a frequency-based bar chart. We wrote code to display a change button and to change from a frequency-based bar chart to a time domain plot.
Part 1. Here is Figure 1 by Scilab. Figure 1 expresses a plot of the music. The x-axis is time, and the y-axis is decibel. The big wave expresses a loud sound. Conversely, the small wave expresses a low sound. First programming means a waveform sizes decision. Second programming means a waveform of the time indicates until 2048 decibels. Third programming means length of the song of indicated a waveform.
Part 2 is a live frequency-based display of audio. It's time to change the display to something that better corresponds to what we actually hear. We load the file by using webload in the first line of code. Fs is the sampling frequency and X is the sample music. In the second line of code, we transport X to be a column vector. The third line code represents the number of channels. The code blklen shows the length of each block and xlen equal size represents the length of the song. In fifth line of code ensures that the song's length is an integer multiple of the block length. The code floor is cutting off numerical value with the number of the appointed figures. The final line of code shows Fourier analysis with a Hamming window of the length of blklen. We send the sound card some music in the first line code. In the second line represents extracting a block of the song. And then we send the current block to the sound card with using msound. And we use the first Fourier transform with the FFT function to compute the spectrum of the block. We further compute the magnitude with ABS. This expresses the absolute of the number in the parentheses in the last line. We convert to decibel. In this second part of the project, The goal is to write a function that will play and display a constantly updated frequency domain bar chart. We express real-time frequency using bars in part 2. Therefore, we used the bar function. By using the mean function, a number in the parentheses is a scalar. The left figure is a snapshot of the bar chart that shows a real-time display of the audio spectrum. Here, it contains 16 bars in which each bar represents a range of frequencies. In the code of this slide, we plot the block frequency 3 iterations of the loop ago. We plot a series of quadratic curves with plot 2D. The function drawLater and drawNow are used by calling the high-level function such as a plotting function when we need to delay updating the plot until all changes have been made.
Window. This code is to display a window. The most important part in this code is each window position. Each window position is x, y, width and height from the left numbers. In this code, 400 is to display a window from the left of the screen to a position of 400. The next 400 is to display a window from the bottom of the screen to a position 400. 600 is to display a 6 width window. 560 is to display a 560 height window. Therefore, a window is changed in regards to its position and area by changing these numbers. Graph. This code is to display a graph. The important parts in this code are hgraph font size, hgraph axis spans, and hgraph margins. Hgraph font size is the size of the axis and scale. Therefore, the size of the axis and scale is changed by changing these numbers. Hgraph axis spans is a part of a figure used in the axis. These numbers are x left, y up, width and height from left numbers. Therefore, the axis is changed in area by changing these numbers. Hgraph margins is margin left, margin right, margin top, margin bottom from left number. Therefore, the margins of the axis are changed by changing these numbers.
When I click play button, I can play music and watch a constantly updated frequency domain bar chart. I show the play button and the program that enables us to click play button. I will explain program code about play. Firstly, unicontrol means making push button. Secondly, string means naming push button play. Thirdly, font name means deciding a type of font of play. Fourthly, font size means deciding a size of font of play. Next, position means deciding position of letters. When I click stop button, I can stop music, and once I click stop button, I have to start music from the beginning. I show the stop button and the program that enables us to click stop button. I will explain program code about the stop. Firstly, unicontrol means making push button. Secondly, string means naming push button stop. Thirdly, font name means deciding a type of font of stop. Fourthly, font size means deciding the size of font of stop. Next, position means deciding position of letters. When I click pause button, I can stop music, and once I click pause button, I can start music from the continuation. I show the pause button and the program that enables us to click pause button. I will explain program code about pause. Firstly, unicontrol means making push button. Secondly, string means naming push button pause. Thirdly, font name means deciding a type of font or pause. Fourthly, font size means deciding a size of font or pause. Next, position means deciding position of letters. I will explain this code. When music is playing, I can't click play button, but I can click pause and stop button. And when music is pausing, I can't click pause button, but I can click play button. And when music is stopping, I can't click pause and stop button, but I can click play button. Continuously, we explain volume control. Please see figure 8. It is a normal volume of photos. Here, look to the right of it. You can adjust the volume. If it slides upwards, volume will become large, and if it slides downwards, volume will become small. Figure 9 is waveforms photos peak by volume. Figure 9 shows that wave is larger than shown in figure 8. As the volume grows, large waves, and also vice versa, volume decreases in the line with waveforms. I'd like to establish such functional programming. First, we explain slide position. This programming represents the slide frame position. This represents the width. This represents the height. Next, explain about the programming of volume setting. This programming that decides the minimum volume. This programming that decides the maximum volume. This programming represents the size of the volume that standards. When maximum volume, it becomes a noise depending on the song. This programming to improve that, we can avoid doing that without noise.
I set the name, font size, and position of the button, like other buttons, by programming this slide code in function create_GUI. We locate the position of the change button next to stop button by make it the one which is x-axis of the change button, 130 pairs in x-axis of the stop button. After having pushed the change button, possible to push a pause button and stop button without code on or off in the function do set playback state value. Similarly, added the same code to a condition after having pushed each button to be able to push the change button when I pushed other buttons. Do it like function callback play button or the reply movement after having pushed the change button using function callback change button. It allowed to drive part 2 code in function callback change button and to convert group from into a frequency wave pattern at time like figure 12.
Our objectives are playing and displaying a constantly updated time domain plot in part 1, and playing and displaying a constantly updated frequency domain bar chart in part 2. Our next challenge is playing and displaying a constantly updated time domain plot and frequency domain bar chart at the same time. Another challenge is that our voice play and display a constantly updated time domain plot and frequency domain bar chart.